Well, guys, I'm coming to you in person now. It's not just my hand, it's my face, because I wanted to tell you how proud I am of you and your accomplishments this semester. This has been an unprecedented situation, and you guys have stepped up in ways that have been completely overwhelming to me. I had no idea what to expect when we went online, and you have far exceeded all of my expectations. You should be super proud of yourselves. This is not the college experience that you chose. A lot of people have to do online because their circumstances will not allow them to be in the classroom, but you chose to come to NOC and be in community with other students and to be in community with your professors, and it did not work out that way at the end. And like I've said, you have just done a fantastic job of taking this on, and my respect for you is off the charts. So I'm teaching to an empty classroom today as we do this Chapter 8 review, but I'm seeing all of your faces, and I just could not be more excited for you about what you have accomplished. You've done a fabulous job. So let's get to Chapter 8. I'm going to go to the dot cam and get off of the screen, and we'll get to work. Okay, Chapter 8. This is it, guys. What do you need to bring with you to your computers when you take this test? You need your calculator, pencils, paper. I haven't been including paper in the past, but I guess you took it anyway. A note card, and reliable Wi-Fi. Those are the things that you need. The theme of Chapter 8 is hypothesis testing. All right, I'll give you a second to catch up. Hypothesis testing. All of the problems in Chapter 8 involve 5 steps. All sections. And so every question on your test, you'll have to go through the 5 steps of hypothesis testing. Step 1 is state your hypothesis. This will involve identifying your null, and it will involve identifying your alternate. Now here you'll either have mu or p equals a number, and here you will have mu or p is greater than, less than, or not equal to a number. Step 2 will be to calculate your test statistic. You have to be super careful here. I think I counted that there's 6 different formulas that could go for Step 2 depending on what you're looking for. So careful to use the correct formula. Step 3 is to get your p-value. Remember, the p-value is a probability value. And you have to be careful with your p-values to know if it's greater than, less than, or not equal to. And what to do depending on which of these it is. Step 4 will be comparing your p-value to alpha. This is how often you might make a mistake to how willing you are to making a mistake with your hypothesis. And this is where you decide if you're going to reject you're null, or fail to reject, you're null. Remember, if P is less than your willingness to make a mistake, you will reject. But if P is greater than alpha, then you will fail to reject. This double negative, I wonder if it's gotten any of you. I almost wish it says accept, but it's not necessarily accept, it just means that you fail to reject, which is a little bit different than accepting, but I don't like the double negative here, and I wonder if it's caught any of you guys off guard. All right, step 5 is where you will write your conclusion. Here you will use words like sufficient and insufficient, evidence to conclude, I'll go ahead and write it, evidence to conclude, whatever your alternate was. If you reject your null, there is sufficient evidence to conclude your alternate. If you fail to reject your null, there is insufficient evidence to conclude your alternate. All right, those are the 5 steps that you will go through on every single problem. Let's take a look at each section individually. Section 8.1. This is hypothesis testing. I'll go and write it one more time. Of mu when sigma is known. Hypothesis testing of mu when sigma is known. All right. These, when you do step 2, you will use the z-table because you have a sigma, and your formula for the test statistic is x bar minus mu over sigma over the square root of n. Now, you have to be careful another place on you, not only using the right formula, but some of them have just the square root down here, and some of them have a square root over the entire denominator. So you have to be careful to not only have the right formula, but know what where the square roots go in them, and to be able to enter them into your calculator appropriately. But this is going to be a z-score because sigma is known. I hope you know that you're testing the average. So you're going to have the word average in your conclusion. And sigma is a population standard deviation. All right, you're also going to have to know, again, what to do when you have the greater than, less than, or not equal to. Less than is the easiest. You're going to use the z-table straight up. Greater than, you're going to have to remember to do 1 minus what you get on your z-table. And not equal to is the hardest and the one we've probably practiced the least. But not equal to, you're going to look up on the z-table and you're going to double the answer because the not equal to's are here and here. So you'll probably get this answer using the z-table straight up, and then you'll double it because it'll be this side too. These two probabilities are equal. So the not equal to is the one you're going to have to probably remember the most. Okay, Section 8.2 is hypothesis testing of mu when sigma is unknown. And on step 2 for this, your test statistic is a t-value. So t-value, the formula is x bar minus mu over s divided by the square root of n. But this is the one where you need a df in order to use the chart. And the df is n minus 1 . Now, a lot of you guys missed this one on the last test. Let me go ahead and show you one of the questions from the last test where you missed it because you thought sigma was known. The tree ring dating question. The tree ring dating of an archaeological excavation site is normally distributed for a random sample of 9 trees whose mean is 1,279 years and a sample standard deviation of 33 years. You guys answered this question. Which distribution did you use? Y'all answered normal, or a lot of you answered the normal distribution because you saw that the standard deviation was given, but you didn't see this word right here. Sample standard deviation. Guys, that's an S. Sigma is a population standard deviation. So be careful. A lot of you guys didn't see that word sample, or you didn't know that the sample standard deviation, you forgot that that was an S. We tried to emphasize what all the variables stood for throughout the semester. All right, so be careful, and that is section 8.2. So 8.1 and 8.2 are just about mu. All right, moving along to 8.3. Again, let's remind ourselves that with these two in your conclusions, you're going to have the word average in your conclusions. Go back and look at the conclusions and see the word average because we're about to change that. 8.3 is hypothesis testing of P. And P is a proportion. So in your conclusion, you're going to have the word proportion. All right, you're going to go through the same 5 steps, but you're going to have P in your step 1 instead of a mu. Your test statistic is going to be a z-value, always a z-value for P. And it is going to be P hat minus P over the square root of PQ over N. Again, I want to point out, I said it a minute ago, but now maybe you're seeing what I'm talking about. In these two, the square root is just in the denominator of the denominator. In this one, the square root is the entire denominator. So watch out for things like that. I hope you know by now that P hat is R over N. That might be helpful for you to remember. So it'll give you a situation where you can figure out the successes over the number of trials and get your P hat. Notice that this doesn't have any P hats or Q hats. These are not P hats and Q hats down here. So just be careful of that as well. That's section 8.3. Okay, 8.5 is the last section. I believe y'all are watching the notes for that today. Maybe some of you are doing it right now. 8.5 is the longest because you have 3 different types of problems. This is hypothesis testing of mu1 minus mu2 when sigma is known maybe I'll call this A. And your test statistic is gotten by this formula. It's going to be a z-value when sigma is known. It is x bar 1 minus x bar 2 over big old square root sigma 1 squared over n1 plus sigma 2 squared over n2. All right, the only thing that are squared are here and here. These are not squared, these are not squared, just the sigmas. All right, and then you'll need to know what to do with your test statistic. I'm not really going over how to find the p-value, step 3, and how to make your decision, step 4. Those are all things you might have to study on your own. You'll definitely have to study on your own. I'm just clearing up the formulas, the proper formulas to use. Our second type of hypothesis testing in 8.5 is mu1 compared to mu2 when sigma is unknown. All right, this is going to be a t-value. It looks an awful lot like this formula, x bar 1 minus x bar 2 over the square root of. The only thing that changes is our sigmas or s's. S1 squared over n1 plus S2 squared over n2. And remember, this one is the one you need a DF. And it's your smaller n minus 1. Because you're given 2 n's, so you take the smaller one and subtract 1. All right, last but not least, you're going to compare p's. And on p's, it doesn't matter if sigma is known or sigma is not known. We don't need a sigma when we're testing p's. So it will always be a z-value. And our z-value will be p hat 1 minus p hat 2. So successes over trials for one group of data, successes over trials of another group of data, over giant square root p bar, q bar over n1 plus p bar, q bar over n2. Now remember, the p bars and the q bars are something different. They're not hats. P bar is your successes, the sum of your successes over the sum of your trials. And then your Q bar is always going to be a complement. It's 1 minus whatever you got for your P bar. Okay, again, like I said, I'm not going over how to take it from there. I just wanted to make sure you have all of the formulas straight, but you're going to need to know how to write these answers. Again, this is comparing two averages. So you're going to have the word average in your conclusion. This is comparing two averages. So you're going to say the average of one compared to the average of the other. And this one, you're comparing two proportions. So you should have the word proportion in your conclusion. So I really hope that that helps you kind of pull it together, or at least puts all of the formulas into position for you. But make sure that you know how to use them. Go back and rework the problems from the notes packet. A lot of you are in a very good shape. A lot of you have A's right now going into this last test, and you can get a B, or maybe some of you even a C on this last test, and still keep your A. So congratulations, that's great. I hope that you're one of those people. And that's all I've got. So God bless you guys. Y'all take care. Have a great summer. If you are ever in Enid, come back and see me. And I hope some of y'all are coming back next semester, and we'll be here in the fall. I can't wait to see your faces.